Ever wondered what it would be like if the night sky suddenly lit up with an awe-inspiring celestial event? Can you imagine a supernova explosion painting the darkness with cosmic brilliance, captivating observers worldwide? Failed to witness such things, right? Then get ready because Betelgeuse, the red supergiant star, is gearing up for a spectacular show. It's not just an astronomical event. It's a breathtaking spectacle that will unite stargazers everywhere in a shared moment of wonder and cosmic contemplation. Get your telescopes ready for an experience of a lifetime. In the vast cosmos, there exists some of the most massive bursts of radio energy known to us. These bursts are so powerful that their impact is expected to resonate throughout the entire universe. Imagine a celestial occurrence so significant that it captures the attention of stargazers worldwide. Think of a momentous event creating shadows on Earth, even in the brightness of day. We might be on the verge of witnessing such a spectacular phenomenon. Entering the Orion constellation, where the star Betelgeuse is currently behaving in a mysterious manner. This behavior hints at an upcoming supernova explosion, promising to illuminate our sky in an unprecedented manner. The question arises, when will Betelgeuse undergo supernova? And how will this cosmic display unfold before our eyes? Before we begin, here's a small thing you can do for us. If you're new to the channel, don't forget to hit the subscribe button. Also press the bell icon right next to it and stay updated with such extraordinary videos. Betelgeuse, a red supergiant, is not your average star. It's a remarkably bright celestial body, shining more than 100,000 times brighter than our Sun. Situated about 650 light-years away in the Orion constellation, it holds significance not just for its luminosity, but also due to its rich history and cultural importance. This red giant, named after the Arabic term Yad, translating to the hand of Orion, has captivated ancient civilizations for centuries, serving as a navigational guide for travelers and a source of wonder for stargazers. Betelgeuse's distinctive reddish hue sets it apart in the Orion constellation. Join us as we delve into the details of Betelgeuse, unraveling its impact on Earth and the broader solar system. Imagine a single star so massive that it dwarfs our entire solar system. To grasp the scale of Betelgeuse, imagine it replacing our Sun. Its edges would stretch all the way to Jupiter. Despite being only 10 million years old, much younger than our 5 billion-year-old Sun, Betelgeuse's colossal size leads to rapid material consumption, indicating a shorter lifespan compared to other stars. This celestial giant, with a volume capable of accommodating over 1 billion suns, is approaching the final stages of its life cycle. As stars like Betelgeuse approach their twilight years, they don't simply fade away. They culminate in a spectacular event. A supernova explosion awaits, a phenomenon beyond human comprehension in terms of energy and brilliance. This colossal event has the potential to outshine an entire galaxy, casting brilliant shadows across vast cosmic distances. The last time Earth witnessed such a supernova explosion up close was in 1604, a time predating the invention of modern telescopes. In contemplating Betelgeuse's grandeur, we confront the marvels and mysteries of our universe, where celestial giants orchestrate cosmic dramas that unfold over epochs, captivating our imagination with the sheer scale and majesty of their existence. Kepler's supernova, the final observed supernova in our Milky Way galaxy, shone brightly for over 18 months, surpassing all other stars in the night sky. It even remained visible during the day for several weeks. This celestial event provides us with valuable insights into the mysteries of stellar remnants. Ancient records from civilizations like the Chinese and European astronomers noted the appearance of this extraordinary star. Today, advanced telescopes reveal remnants of the explosion in the form of an expanding debris cloud. This ongoing observation helps us understand the dramatic conclusions of massive stars. Historically, supernovae were rare events observable from Earth. Now, a stellar explosion so intense that it rivals the brightness of a full moon, casting shadows at night and being visible during daylight. The radiation from such an event could impact our atmosphere, affecting satellite operations and possibly the climate. Betelgeuse, known for its unpredictable dimming patterns, hints at the possibility of such a grand spectacle. Are we on the brink of witnessing one of the universe's most dramatic events? Recent revelations by astronomers show that between October 2019 and early 2023, Betelgeuse underwent a remarkable transformation, drawing attention from astronomers and enthusiasts worldwide. In a fascinating event known as the Great Dimming, the consistent brightness of a star that had persisted for centuries began to diminish noticeably. This sudden change caught the attention of even casual stargazers when they compared Betelgeuse to other stars in the Orion constellation. This phenomenon hinted that we might not be centuries away from witnessing its supernova explosion. In fact, it could happen in mere decades or even less. By April 2023, astronomical observations indicated that Betelgeuse had returned to its usual luminosity levels. Many believed that the period of anomaly had concluded. However, in a surprising twist, the subsequent months witnessed Betelgeuse's brightness increasing by a remarkable 50 times. Such fluctuations, though common for variable stars, were unexpected for Betelgeuse, which had previously displayed predictable luminosity cycles. This sudden and intense surge in brightness brought the star back into the limelight, sparking discussions about its immediate future. The sudden change in brightness of Betelgeuse stars, contrary to just being twinkling dots, are dynamic entities with their own life cycles, activities, and mysteries. Similar to Earth's seasons, many celestial bodies exhibit periodic brightness variations. Betelgeuse, over its stellar lifetime, has shown a consistent 400-day luminosity cycle. However, the recent phenomenon of the Great Dimming defied its usual behavior, challenging our understanding of celestial wonders. Scientists are still figuring out why Betelgeuse acts strangely, but one interesting idea is that what stars do and how much stuff they throw out can be a big part of it. Now imagine Betelgeuse as a colossal celestial volcano suddenly erupting, releasing an immense amount of its matter into space. Previous observations from the Hubble Space Telescope have shown that Betelgeuse has ejected a substantial portion of its surface material into the cosmos. This tantalizing scenario is at the center of the emerging explanation for Betelgeuse's intriguing behavior. And this celestial phenomenon recently underwent an extraordinary event, ejecting a colossal mass that surpassed the norm for solar occurrences by a staggering 400 billion times. This expulsion, equivalent to several times the mass of our moon, had a profound impact, giving rise to a dense dust cloud enveloping the star. This cloud affected the star's apparent brightness, rendering it temporarily challenging to observe. As time unfolded, the dispersed dust or the force of the star's radiation pressure pushed it away, unveiling the star once more. This unveiling potentially explains the subsequent return to regular brightness levels. Intriguingly, these recent events suggest that Betelgeuse holds more surprises, sparking speculation about the star possibly approaching the twilight of its life, a supernova event. A supernova, a cataclysmic explosion of extraordinary energy, can momentarily outshine an entire galaxy. This phenomenon typically occurs due to a sudden change in the star's core. In Betelgeuse's case, this could result from either absorbing excessive matter from a neighboring star or the exhaustion of its nuclear fuel. The latter scenario triggers a cascading effect, leading to a cataclysmic collapse. The demise of massive stars like Betelgeuse stems from the gravitational collapse of gas within molecular clouds. These stars embark on their cosmic journey by burning hydrogen in their cores during the main sequence stage, a phase lasting millions of years and forming the foundational backbone of a star's life. Betelgeuse's recent events thus hint at a celestial entity on the brink of a spectacular transformation, leaving astronomers and enthusiasts eagerly anticipating the unfolding cosmic drama. As stars use up their hydrogen, they go through changes, finding new energy sources. Take Betelgeuse, for example. When its hydrogen runs low, it starts burning helium, forming carbon and oxygen. This shift from the main sequence to the helium-burning phase makes the star expand into a red giant. As helium decreases, the star expands more and goes through different burning phases. Bigger stars go through these transitions faster due to intense gravitational pressures. The critical moment arrives when iron begins to form at the core. Unlike lighter elements, iron fusion doesn't release enough energy to counter the star's gravitational pull. The star swells and undergoes an implosion, followed by a powerful rebound, resulting in a supernova explosion. Now, the question is Betelgeuse on the verge of a dramatic end, or is it just taking its time? Recent research from Japan's Tohoku University suggests that Betelgeuse might be in its carbon-burning phase. Hideyuki Seo, the lead researcher, believes that the star's core might collapse a few decades after its carbon reserves run out. In simpler terms, stars change as they use up their fuel, and bigger stars change faster. When iron forms in a star, it can lead to a spectacular explosion called a supernova. Betelgeuse might be going through one of these phases right now, and researchers think it could collapse in a few decades after using up its carbon. Not all scientists agree, but studies from Hungary's Konkoly Observatory suggest that Betelgeuse is possibly still in the earlier helium-burning stage. Regardless of these debates, scientists unanimously agree that Betelgeuse is destined to become the Milky Way's next supernova. However, predicting when this will happen remains a cosmic guessing game, with estimates ranging from a few decades to a staggering 100,000 years. Amidst these scientific discussions about Betelgeuse's fate, one undisputed fact stands out: the nature of our observations. When we gaze at the starry expanse, there's a subtle paradox we often overlook. This paradox is tied to the fundamental aspects of time and light in our vast cosmos. Stars and celestial bodies are so far away that their light takes an immense amount of time to reach our eyes. For instance, despite light traveling at an astonishing 186,282 miles per second, it still has its limitations. Consequently, the light from distant stars and galaxies takes its time to traverse the vastness of space before gracing our sight. When you look at Betelgeuse, you're actually witnessing a spectacle from 650 years in the past. To put it simply, when this light began its journey towards Earth, the Renaissance was just beginning, and explorers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is akin to peering through a cosmic time capsule, offering us glimpses into its distant past. So, even if, for the sake of argument, Betelgeuse had already exploded in a magnificent supernova, we would only be seeing that event now, providing a unique perspective on the unfolding drama of our universe. We might not know about it for another 650 years, but as we talk and guess about the upcoming explosion of Betelgeuse in the vast universe, this big event might have already happened. We're just waiting for it to travel through space and time until it reaches our telescopes. Recent findings about Betelgeuse have sparked lively discussions in the astronomy community. People are comparing it to another amazing discovery from this year, SN 2023, a supernova observed in a galaxy near the Milky Way. This distant explosion reminded everyone of how dynamic and unpredictable the universe can be. SN 2023 was special in its own way. It was millions of light years away, but showed a spectacular burst of light that briefly outshone its home galaxy. What caught the attention of scientists and casual observers alike was its striking similarity to what many think will happen to Betelgeuse. The spectrum, intensity, and aftermath of the explosion gave us a fascinating peek into the processes that massive stars go through as they reach the end of their lives. For many, SN 2023 served as a preview. If Betelgeuse eventually meets a similar explosive fate, the sequence of events may look a lot like what we saw with SN 2023. The link between these two celestial events highlights a big idea about how everything in our universe is connected. It doesn't matter if it's a nearby star like Betelgeuse or a faraway supernova like SN 2023 ISF. These space happenings teach us about the ever-changing nature of space. When we look into space, there's so much we don't know. It's like exploring uncharted lands filled with mysteries we haven't solved. This is especially true when it comes to red supergiants like Betelgeuse. They are incredibly bright and mysterious, holding some of the universe's deepest secrets. Even though scientists have a general idea of how red supergiants live their lives, there are still many things we're not sure about. As these stars transform from one phase to another, there are parts of the process that we don't completely understand. The steps in between, which might involve major changes in the star's core, are still being studied and debated. Red supergiants are also known for releasing large amounts of material into space. In the later stages of a star's life, a crucial process occurs that shapes its evolution and leads to supernova explosions. However, the details of how stars lose mass, the rate of this loss, and the triggers for these explosions are still unclear. Betelgeuse, with its recent fluctuations, adds to this uncertainty. If Betelgeuse were to undergo a supernova, what would be the consequences for the cosmic drama unfolding? Dr. Stanimir Mitev from Western University suggests that when Betelgeuse finally explodes, it will briefly become one of the brightest objects in our sky, outshining all other stars and possibly some planets. Even at its vast distance of 650 light-years, the brightness could rival or even surpass that of the Moon. This intense display would turn the night into a pseudo-day for weeks or possibly months, significantly altering our perception of the Orion constellation. In the following months, the brightness would fade, and after decades, an outer shell of the once vibrant star would appear as a planetary nebula, surrounding the dim remnants of its core, as observed by astronomers. Astrophysicists around the world are studying what might happen if a particular event occurs in space. Some people think there could be an explosion that releases high-energy particles called cosmic rays. These particles travel really fast through space, almost as fast as light. As they move, they might bump into stuff in space and make it charged. When these cosmic rays get close to Earth, they could interact with our magnetic field and create beautiful auroras. But does this mean we'll have serious problems on Earth? Luckily, Betelgeuse is far away, so these rays would probably get spread out and absorbed by our atmosphere. This would have a minimal impact on life on Earth. Even though the explosion itself won't directly harm Earth, the light show it creates will definitely get people talking and might lead to more research and some worries. But what about our human-made wonders, like satellites orbiting Earth? The increase in brightness, along with possible gamma and X-ray radiation, could affect satellite operations, especially those in higher orbits. In order to protect our satellite infrastructure from high-energy particles resulting from an explosion, scientists may implement measures. Additionally, they will closely monitor the Earth's atmosphere to understand any potential impacts of increased radiation. The aftermath of such events could bring unexpected consequences. Imagine what the explosion of a distant star might sound like.